Welcome to Elixir Mix, your weekly Elixir podcast talking with members of the community. My name is Mark Ericksen, and on our panel today we have Michael Ries.
10 points to Gryffindor.
And today we are joined by John Mertens. Hey John, can you say hi?
Hello everyone from Sultry, Portland, Oregon.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code devchat at Sentry.io to get 2 months free on Sentry's small plan. That's code devchat at Sentry.io.
So John, I saw a recent talk that you gave, and it was an awesome topic about, it was titled Lessons from Our First Trillion Messages with Flow. And if that isn't a clickbaity thing and like interest grabbing, it's like, I don't know what is. So like, at least for our ecosystem, our little community. So that was an awesome one. And we wanted to have you on and talk about kind of what you've been doing and learning. So why don't you first kind of give us a little background as to where you work and what kind of problems you're solving?
Yeah. So I'm a software developer at change.org. If you've signed an online petition in like the last 10 years, you probably got it from us. What's more salient to this conversation is I probably, after working there for a few years, mostly in Ruby and JavaScript, introduced Elixir into our stack when we had the opportunity for a new greenfield project, which I'll be careful to talk about because it sort of involves getting rid of a vendor, and I'm not going to say who that vendor is just yet.
Nice. Okay. Well, that is an interesting topic just because I know we've talked about it a fair bit on the podcast, just the idea of how to bring Elixir into an organization. There's a lot of people out there who are interested in Elixir and want to work with it. So they're saying, well, where can I go to find a job? And lots of times, at least in this early stage, the best answer might be learning about it on our own and then finding ways that it can solve the problems at the business where we currently are. And so I'd love to hear about, your kind of, sounds like you came from a Rails kind of background. How did you kind of start learning about Elixir? You must have been playing with it on your own. And then you said, hey, I think this can help us. I'd love to hear about that.
Yeah, you pretty much nailed it. So one thing, shout out to Change, has an amazing parental leave policy. So when we had our second kid, I had 4 months off of parental leave, and during that time, while my son was sleeping and I was sitting next to him, I was like very enamored with. I'd heard a bunch about Elixir, and I was like, well, let me try this out. Let me start messing with this. Let me do a little research, and made a few toy apps and got up to speed on it. And then it started becoming that thing where I was like, you're like, I understand the types of problems that this is good at solving. And like, I got a hammer and I'm looking for a nail. And so when I came back, I was doing my regular sort of Rails backend services, JavaScript front end, day to day. And then this opportunity came up when we were talking about this sort of replacing this vendor that I was talking about with a new greenfield sort of communications, basically big data processing app. And I just kept raising my hand in meetings and being like, I know this thing called Elixir that would be perfect for this problem. And said it a few times and finally got invited to the meetings. And I mean, this is also from like a position of privilege where I'm a high ranking in the organization engineer. And I keep mentioning this stuff until they find like, okay, let's do a proof of concept challenge was essentially what it was. And my former manager had the great insight to say like, cool, let's try to settle this. Let's set up a test problem that represents essentially what we want to do. And then we'll do it for different languages, paradigms, and then see which one comes out. And we did the dual scale of performance and developer happiness. And I don't want to talk trash about any other languages, but like we did the proof of concept with, I did Elixir, somebody else did a Node one, somebody else did a Scala implementation, and then someone else, because we all like in our hearts, we're like, I hope Ruby wins, but I'm not really holding out for it. And so we did an implementation of JRuby, and of those, Node and Elixir were the most performant. And then we did a second round with a more complicated problem, and it ended up essentially being like 20% faster. And then the developer experience was like, I was like, this is a library written by the same person who wrote the language. Like, this is very good. And here's this thing called HexDocs, and like showed everyone, and I was like, this is super easy to look stuff up, and here's the forum, and everybody's really helpful. And like that like was bonus points on it. And so with that sort of data in hand, the powers that be were like, fine, do it. It sounds good. Go for it. And so myself and two other people just started building the system in Elixir, and which has a funny side effect is that I'm not very good with Phoenix, I've found, because I've been working in Phoenix recently, and I feel like that's like what everybody does in Elixir. But the first two, basically we built 3 apps simultaneously that handle different parts of the system, and the first 2 were OTP apps, and that's my day-to-day is in that. And then the other, I wrote a PR for a Phoenix app yesterday and was like, this is how we do it here. This is different. I need to remember how to do that. But in terms of like adopting it, another thing that helped was I was literally in a meeting where we were discussing how to adopt Elixir and like pitfalls and things like, how do we deploy this thing? How does it fit with our current config management? And I got an email from Prague that moment saying, we have this new book. It's called Adopting Elixir. And I was like, everyone hang on just a second. I have to buy something.
That is awesome.
So, and the other big thing that we did is we reached out to Platform Tech to see if we could get augment our knowledge with one of their consultants, and got an interesting response because they were like, unfortunately, everybody's booked right now. We couldn't get you on for a few months, but we have this program that we haven't started advertising yet, but we're just about to start it. And it's this, I'm going to blank on the name, but essentially like a developer assistance program. And you get a consultant that you have like unlimited email support. I end up tagging them on PRs and stuff. And it's very affordable and super helpful. And since we were in at the beginning, our consultant was Jose. And so we had a lot of things where we're like, hey, Jose, this is the problem we're solving. We think this is right. And he would be like, oh, you should tweak this. Or like in his very nice way, being like, you guys don't understand supervision trees properly. And showing us the path forward. He would obviously never say something that scathing, but he very much led us in the right direction. And that basically put us on the right foot and has been super helpful ever since.
Wow, that is really cool. So you had very timely resource of the Adopting Elixir book, and then being able to actually be able to work with Platform Tech and with their covert program, and which I don't think I've seen announced yet either. And then yeah, so like being able to work with Jose, that's awesome. So because like he mentioned when he was talking about Broadway that he had worked with several companies who are dealing with specific problems with large data pipelines, and you said in your talk, yeah, he was working with us as one of them. So like that's cool. It kind of like puts it all together now.
Yeah, we were one of a couple, and it's funny when I hear him talk about Broadway because I'm just like, that was our problem. Like I'm sure other people had it too, but it's like you start dealing with stuff like pulling things from SQS, and like we had written a whole library that would handle that and turn it into a producer, which I could not. I went back and tried to find it. I blatantly stole the code from some blog post and just put it in our lib. And then I looked at like the Broadway SQS producer, and it looks just like our code, but there. And I'm like, I'd love to give credit to the original author somewhere. This is, I could not find it again. But yeah, it's funny that that's it. When Broadway was announced, it was very much like, this solves exactly the kind of problem we're solving. Yay.
So I think I'd like to interject just a quick note for listeners, especially if you are thinking about trying to get some Elixir adopted at your company. Being, like a senior engineer with kind of already some social credit of having delivered some things in the past is a great way to help push that forward. But I also want to encourage people, if you're a fairly new programmer on your team, I've heard of lots of people who successfully managed to pull it in maybe more focused ways. So I know of one person who pulled it into a project. They had a pipeline where one team of people were writing C++ code, like basically game engine code. And then they had to kick off CI jobs where they would compile that into Android apps and into iOS apps and install it on a bunch of different devices. And they kind of had some of these things already cobbled together, but they wrote a little Phoenix app that kind of sat in the middle of this pipeline, and it would automatically kick off things and then push them down to the devices, like trigger a download to the different devices and make sure that the app booted correctly, etc. And that kind of became an important little piece of their overall developer success. And they were able to deliver quite a few things, and it was a great chance to write some Phoenix at work. So don't feel like you have to wait until you've been there for 3 years or something to try to get an Elixir project off the ground. It's worth a try. And if anyone's ever struggling with that, I know personally I'd love to, I'd give my 2 cents on how to pitch it to your company. I'm sure John or Mark, I'm just going to volunteer both of you as well. People can reach out to us and, pick our brains on how to pitch that for work.
Certainly.
I totally agree with that. And I actually wrote a proposal for a talk at ElixirConf USA last year. That was essentially like, here's how you don't adopt Elixir. And it was like, you do a big greenfield, super important, like mission critical system in it from the start. I was like, this is against all good advice. Like, you should start small and let it, seep out.
Yeah, it is interesting because I just know from my story, it was a lot of talking about what I was learning about. Like, wow, this is so cool. Just kind of sharing my excitement and my enthusiasm and like showing examples of how it was different from what we were doing and how it could help. But I also didn't have that experience, where I could come in as an expert and say, this is how we need to structure everything and we'll be awesome from the get-go. Like, that's that whole like greenfield project. It's like, hey, this is a major investment of the company's resources. And I'm just guessing at how to do this, right? I have belief in this as a good tool, but I don't yet have the experience to say it will 100% solve this and I know how to do it. So yeah, I agree with both of you. Like, a lot of times it is very helpful to bring it in small pieces and small ways, and it helps other people get comfort and experience with it too on the team.
Another, like, along that continuum of adoption thing that we've been trying to do is that so it was just, we've changed it over, still primarily Ruby and JavaScript. And this one system that we've built is in Elixir. But as things have been growing and Elixir's been performing amazingly well, we have done things like we started a book club that went through at the beginning of the year, that went through learn functional programming with Elixir, which was interesting. It got people that weren't on my team a little bit more exposed to it. And that has since evolved into this community of practice around Elixir that we have in the company. And so the people that may not be working with it every day get together with people who are. And I think right now we're trying to get a baseline. So we're going through the Dave Thomas Programming Elixir book and like answering questions, but we're trying to spice it up with like, here's a Elixir problem that we had today, or like, here's little code bits from pull requests that are like, oh, here's a comment I gave to someone, so let me just share it with the group and try to build that practice out. And we have a few more Elixir applications in the pipeline now, and like we're trying to just build out that knowledge.
Very cool.
This episode is sponsored by GetLab Commit. GetLab's inaugural user event brings together the GetLab community to connect, learn, and inspire. Speakers will showcase the power of DevOps in action through strategy and technology decisions, lessons learned, behind-the-scenes looks at the development lifecycle, and more. Learn how to innovate the future of software development by registering today. GetLab Commit Brooklyn, September 17th, and GetLab Commit London, October 9th. You can find it at devchat.tv/GetLabCommit.
So I know, let's jump into the topic. It was about Flow originally. And one of the things I wanted to make sure we talked about on the podcast was that, Flow is not part of the standard library for Elixir. It is an external kind of, it's still official, but is not part of the core library when you install Elixir. It's in a hex package, and it is an abstraction on top of GenStage, which is also something that's not in the core. But it's something that I think is worth talking about, because people who are coming to Elixir, they may, if they're just looking at what's in the standard library and what's available to me, they might not see it very quickly. So it'd be nice just to know, help people understand what this is, that this is something that's available, and how you guys used it. And then I definitely want to touch on how you ended up jumping into Broadway and solving those problems, and like what problems you encountered in Flow. And just kind of, I'd love to hear that story. So I was curious as to, so I'd love to just hear, how you got started with Flow.
Yeah. I was trying to think about this, and I must have seen Jose's talk on it when it first came out. And I agree, like it not being part of the standard library, even though it like originally was intended to, like that in GenStage, was something that I was like, in terms of evaluating solutions, I was like, oh, is that a red flag? But I saw, I think it was a blog post or something where Jose responded, and it was basically saying like, we want it to be not tied to the language. We want to be able to iterate on it. It's sort of, it was in the experimental branch, and then we pulled it out, and that way things can happen on top of that aren't part of the main language. I think if you were to ask me today, should GenStage be part of the main language? I would probably say yeah, because it's so, we're like 7 layers deep on abstractions right now, because like the Gen server, and then GenStage is on top of that, and then Flow is on top of that. And then Broadway is also on top of GenStage, but right next to Flow. Like it's they're all sort of built on that. I think that it not being part of the library is, I agree with the idea of like, let's iterate on it. Let's be able to work on that independently of the language. But yeah, I think maybe this is just my impression, but I feel like a lot of people come to Elixir from a web application standpoint, and they want to have an API or produce a website. And so like Phoenix is a natural fit for that. And I don't know, I was sort of inspired by Jose's introduction talk about Flow and GenStage in general. And I was like, man, in my career, there had been so many problems where I've had like this huge flow of data, and essentially like back pressure was the thing that I always wanted and didn't really implement. Back pressure and like this idea of like, cool, if you just open up the valve, all of your CPU cores will go as fast as they can, and that's not a bad thing. That doesn't mean you're over your machine's going to fall over. It's happy to run at like 95% all the time with the beam, I should say. But like that, yeah, that's essentially like Flow not being included is not that big a deal, but it does involve us proselytizing more about it and getting people in there.
I'd love to know just a little bit about, can you explain a little bit about what the pieces of data that are going through your Flow pipeline look like? What kind of outcome are you trying to achieve with those? I think that might give us a little more context for then how you used Flow or why you would have picked Flow.
Yeah, I realize nobody knows what's all the context in my head. So we have a system where basically think of like an event system where like people are doing stuff on change.org, they're signing petitions, they're starting petitions, they're, promoting petitions, they're doing all these things, and all these events are getting piped out onto some sort of message bus. There are certain messages that the system I'm building cares about. And so we have, in good distributed service fashion, we have something that reads those messages off the message bus going by and puts them into a big queue on Amazon SQS. And then we just need to do things with those messages. A lot of times it's like, we'll need to send a message to someone, like, or we need to, increment something or do something, deal with that data. As far as shapes, it's usually just a JSON block that you would send through. SQS messages will take strings, and so we have a stringified JSON blob that like comes through, and it has details about like the message type, and that indicates some data that should be present. Maybe we need to reschedule this event to trigger something later. All kinds of business logic stuff that needs to happen, and then at the end we hook up to like an external API and do stuff like shoot off emails or like pipe out analytics and things like that. And so it's good to have like sort of things come off an SQS, get processed by one system. Anything that makes it through that goes to another queue, which gets processed by the second system. It does a lot of actions. And then we're done. And then it like acknowledges the messages and those are done. And so having a system where, we send an update to or a petition starter sends an update to their people who have signed their petitions. And let's say there's 5 million people who have signed their petitions. So then suddenly, at least 5 million messages hit our system almost instantaneously. And we need to chew through those as fast as possible. But we don't want to push them in so that it knocks our machines over. And that's where this back pressure thing comes in. And pulling from a queue is a perfect setup for let's pull as fast as we can and no faster. And I think that's where GenStage and Flow and Broadway all sort of shine in that, because they're all built on GenStage.
Would it be fair then to say, listening to this, so there's kind of some database updates that happen, there's some sending out of other types of notifications. This sounds like a mostly IO bound problem where you're not wanting to overrun the downstream systems. So you're a little bit careful about the level of load, but trying to do as much in parallel as quickly as possible within those constraints, which sounds very much like it's not necessarily number crunching, but it's about trying to get a lot of work started and waiting for it to complete other places and kind of the coordination of those things. Is that roughly on target?
Yeah, it's almost exclusively IO bound, doing database reads, database writes, writing to logs, emitting stuff to Kinesis Firehoses and things like that. But yeah, which is why, and the other key point of this is they are essentially independent from each other. So that lends itself very well to this sort of parallel processing. So yeah, that's where if it's IO bound, we just try to process, we turn up all of our max demands and GenStage speak to make sure that we're getting as many things in there as possible.
That was one of the interesting things that you mentioned in your talk, was the idea of tuning it. And I think it'd be interesting to hear your process for tuning that. How do you decide the number of producers and consumers and the demand levels? Because it is really just, it's unique to your situation and, the types of data that you're processing. Kind of what was your process for how you figured that out?
Yeah, I touched on this in the talk, and I basically, to start, and we've moved on a little bit since then, but originally I found a really great blog post that basically showed an example of at each one of your stages, cast out an event to a Gen server, and it will just pick those up, and then you could turn that into a graph that would show how long each one is working, and if you're getting stuck somewhere, and that's a good low fidelity sort of knob turning to get to one spot. And then another thing is to learn. It's weird because it's sort of I learned this through discussions with Jose and the team of just what is this section of the flow doing? Oh, and this one, it's it's the producer stage. So we need to set our max demand to 10 because we know conceptually in our case that SQS will only give us 10 messages at a time. And so in order to make that most efficient, if we set our max demand to 100, we have to wait for 10 round trip HTTP calls to get that data before it can move on. But if we set it to 10, then that's one batch in and out, and we go really fast. And at that level, it's cool, we could just have more producers that each are asking for 10. If we have 10 of them asking for 10, that's way better than one of them asking for 100. We don't do 10 yet. But yeah, there's that's one level, is to go in and think, what am I doing right here? And what are the knock-on effects? And it's, I wouldn't say frustrating, but it's you actually need to sit, there's no one size fits all solution. Is you have to go through and be what am I doing at this stage? What does that sound like? Tune the numbers, test it, tune the numbers again. Look at the output, tweak it again. But a lot of that was stuff I did before we went live with this thing. And now that we've been live for over a year, where it's more of have good observability and good monitoring. And so we had an issue a few weeks ago where processing time was taking a lot longer for one of the services. And we ended up going through and as a message passed through the flow, we have sort of a generic metadata field on that structure. And we could put in there for each stage, drop the time stamp of it in there. And then we could figure out, break it down and determine oh, this is probably, we have the max demand too low here or something, or we have it too high and it's waiting on something. So let's tune that down and get it through faster. Fun side story on that is that was looking at our one of our services code was going a little bit slower than I thought it could be. Basically, since we have two services that are right next to each other, we're always comparing them and seeing which one can go faster. So this first one, I was like, oh, we don't have a max demand set on this. I feel like I did that. And then I went back and there's a slide in my talk where I show the code that I'm talking about now, and it has a max demand of 1,000. I was like, I just never put that in the code base. Like I thought I did. I told people I did, and now I'm looking at it, it's not there. And so my pull request was basically a screenshot of my talk with an arrow pointing to that number and being like, this is supposed to be here. And that improved, throughput.
That's awesome.
Conference-driven development, but just without the development part at the end. One question I had was, as I was thinking about potentially putting together a system like this, how well do the kind of out-of-the-box observability tools that come with VM work? So for instance, Observer, if I kick it off, are there just going to be so many processes that I can't really make sense of it? Or have you found things like Observer to be useful in terms of kind of peeking at your system and having some sort of mental model there?
So somebody with more experience in Observer will probably cringe at my answer, but I have a layman's knowledge of it. And essentially, I like to pull up an Observer and make sure that I mostly look at CPU utilization, and then, or on the like processes chart, I want to see that their expected number of processes and they all have like the highest, reductions or reds is the column. Like, cool, all of these are working really hard. That's what I was expecting. But as far as like more granular from that, I haven't like gotten into it enough to give like a salient answer on that.
Yeah. So you mentioned the importance of observability, which I was curious, have you been applying telemetry or anything like that to be able to get metrics out? You mentioned like doing timestamps on some of the entries that you could help to kind of back into the time durations, but I'm just kind of, have you looked into telemetry and have you gotten any value out of something like that?
I am personally excited about telemetry. One of the downsides of this new project is that we have some hard deadlines that we're racing towards, and there is a pile of Jira tickets labeled as tech debt, and one of them says add telemetry. And we're not quite there yet, but I'm very excited to like get to that point. I know people on my team are like, we should do this. So in the meantime, we basically have those events that we just write on the struct. One little engineering thing is, instead of at the end of the day, all those numbers get shipped off through StatsD or something. It goes to SignalFX, but like we made the decision to put all of that shoot off at the end as opposed to like individual ones, just to like make sure we got through the system as a whole without slowing anything down. But yeah, no, I'm super excited to use telemetry. I just have not had a chance yet.
One thing that we touched on briefly was there's kind of this tree of core Elixir, GenStage, and then Flow, and Broadway kind of developed it's a sibling. It doesn't depend on Flow, but has a somewhat similar structure and is tuned a little bit more for use cases like message acknowledgement and handling things like Graceful shutdown, sort of a little bit more out of the box from what I understand. Is that something that you guys have looked at, are thinking about, or maybe have already started to evaluate?
Yes, I have a very stale pull request against one of our repos to convert it to Broadway. And that was like, doing that was sort of the impetus of the end of my ElixirConf EU talk, was essentially like, this was really easy to port over because it fit the model that we had. The only problem is we had two things named SQS producer or something, and we just had some namespacing delicacies to deal with. But other than that, it fit our solution probably better than Flow does. And one of the things I'll mention in the difference is that the best thing that Broadway does, besides it having a concept of like producing essentially from SQS and like acknowledging messages, that framework, is that it has this concept of batching. And that's something that we sort of like shoehorned into Flow. On another project that we used, we set up a batching mechanism just using GenStage. And so it's a lot more manual wiring of processes together. But it got us the sort of like distinct, granularly partitioned batches that we wanted. And that was better. which is why I think it's, did I mention the pile of Jira tickets? One of them is to like, let's bring over this stuff to Broadway. And I also get the like guilty feeling when Jose's like, have you guys gone over to Broadway yet? And I'm like, not quite. But him and the team have looked at like my PR and we've given feedback like, yeah, this was super easy. And they wanted to know like, is it doing the things that we want and that kind of stuff? And it definitely is. And it's just, I want to stop doing other projects and just make us use Broadway now.
Nice. I know. So one of the questions I had about Flow versus Broadway is, Flow can be very readable just to look at the code. At least I feel like it is. Like it's kind of like a pipeline. And Broadway, the configuration is a little bit more, data structure like, and so it's not as easy to just like look at and understand necessarily without maybe a little bit of experience. I was just curious as to how you felt. You kind of touched on it there, but just like how do you feel they compare in terms of configuration and understanding what's going on?
It's a good question. I feel like the more I learned about Flow, the more powerful I felt in it, and which also made me appreciate more of what Broadway was doing. So I followed that progression, which is why it feels like Broadway is a nice fit for the problem that we're trying to solve. But I totally agree with like Flow. You can say it looks like a pipeline. Like you just line them all up, pipe one into the other, and a lot of there's a lot of magic behind the scenes that just is setting up gen stages in the background and doing this work. And then I had a few good conversations where Jose kind of showed me a couple of things where it's like, see this series of flow.maps that you have in a row? In the behind the scenes, it's going to just turn all those into one map. Like I could write flow.map and then put those 4 function calls or whatever all together. And it would be equivalent to writing flow.map 4 times with one function, independently. Which I mean, I like the more pipeline-y looking one. But like it was one of those eye-opening moments to be like, oh, that's how that works. And then I went looking in the code and I could see how Flow basically, like, you think of like a stream where it builds up a function, then Flow is doing a very similar thing that is just building up like, oh, cool, I've got a mapper, add it to the mapper list. Oh, there's another mapper, add it to the mapper list. Oh, now I've got a partition. Now I got to put this partition in the like Flow data structure that it builds up. So that the thing I like about Flow is it's very approachable because of that syntax. And then you start to, it's basically once you've gotten into it and then you start reading more about it and then you understand more of the power around it. And like if we didn't need batching on ours, like I think our system would look slightly different because we're sort of turning a partition into a batcher mechanism that we do, which is a weird little dance that we only got there after evolving a few times.
That's cool. So another question I had about, because I saw in your presentation, you talk about, and in case we hadn't mentioned it, check out the show notes for a link to the presentation. It's a great resource. It's something you can kind of share with team members if you wanted to kind of introduce this topic. But you talked about like showing how in Flow and in Broadway, you're looking at the supervision trees and Observer, kind of like how the application is kind of structured in terms of the processes and the supervision trees specifically. And you're talking about how you had that little Terminator gen server. And so one of the things that Broadway is helping to solve that Michael had also mentioned was the idea of a graceful shutdown, so that I can tell the producer to stop taking on new stuff because the system needs to go down. And in a modern DevOps environment where we're kind of doing rolling deploys and it might be multiple times a day, that's going to be something that can happen fairly frequently. And you're trying to avoid the problem of missing messages where they've been pulled out of the queue, but they haven't been finished and the system shut down in the middle of it. So I was just curious as to how that went with you and like how you discovered that, oh, I have a problem, I'm losing messages, and how you kind of solved that.
Yeah, that's a big deal for us because we did a couple of things to handle that. Yeah, one is essentially at every point in the process, like internally we use blue-green deploys. So basically our servers up, we build a whole new set of servers and then just swap them out. There's no load balancer, so we actually just have to turn one off and then things back up in the queue for a second and then turn the other ones on, which works fine in this kind of not website environment. So that is something that we at every step had to be like, so what if it crashes right now? What happens if it blows up right now? What happens if something happens to the data center at this moment? So we did a couple things that sort of, the concern was there. And And it was those are one of our known unknowns, and we were always worried about the unknown unknowns after that. But some of the things that we did code structure wise is what we didn't want to, like using SQS. If a message enters the system and then gets dropped before any side effects have taken place, we're good. It will just not be acknowledged, and we have like a 5-minute thing on our queue. So after 5 minutes of not hearing that it got acknowledged, it just gets put back in the queue and we reprocess it. So we wanted to make sure that the side effects that happen, and by side effects, I mean like writing to databases, changing some data structure outside of this, happen right at the end. It's like the last thing that happens before the message is acknowledged. So that way we at least I know we're talking like nanoseconds here, but like the conceptually we do everything else, and then right at the end we commit it, and then we acknowledge it 1, 2 real quick. So that way, if we did need to do something or handle a case where we're calling it to an external API right at the end and that fails, that we do a thing to sort of roll back any changes that had happened earlier. And that's just in sort of external failures. So that's just something we have to take into account. But then internally, we were running without a good solution for this for a little while. And we started talking to Jose and the team, and it had been an outstanding task. And then he and I had an email exchange that he basically explained all right, you need another process that you start last. I should have looked this up first, but basically that terminator process that essentially listens to when the terminator the shutdown signal occurs, because the ones at the bottom of the supervision tree will get those first, and it will trap that exit and make a call to the producers that says stop, and they will stop producing, but anything that's in the queue can continue to go through. And then basically once the way Flow is set up, I think if you tell the Flow to stop, it will let things flush, but it won't do that automatically unless you set up a process beforehand. And so it's going to call the producers to stop flowing, so that'll go through, and then it'll tell the Flow process to shut down, and then it waits for that shutdown to happen, and then the thing shuts down, and then that whole branch of the supervision tree shuts down. I realize no one can see my hands waving around, and I'm trying to draw that with my hands. Sorry about that.
I understood it perfectly. So one of the questions I have had with that, and I don't know, maybe you can speak to this or not, but I have with my supervision tree and my whole application, I have other parts of my tree that are separate from this gen stage, this Flow. And one of those could be my database repo. And what guarantee do I have that it's going, the gen stage, the producer's been notified, it's going to let it drain, but my database is gone. Can I be any kind of guarantees that certain things aren't closed first?
I mean, generally that depends on how the tree is built. But I think, specifically for our case, if that were something to happen, then all those messages that were draining would try to hit the database, and they would error out and then get thrown back in the queue to retry. So that one sort of solved it. We solved it with the external mechanism as opposed to a supervision tree mechanism. But I think, this is an area where I need to study more, but I think it makes a lot of sense if you're doing something like that, to read through the supervision docs and get that kind of set up. And that's the other thing where I like to use Observer, because I find that super helpful to see okay, well, if this goes down, it's gonna, and just know the basics. So the leaves go down first and it goes up. All right, now let me think what's gonna happen there. And then I don't know about you guys. I've read the definitions of the different shutdown strategies or restart strategies 100 times, and I have to read through them every time again. So, that might be a piece that's lacking in naming, where I'm what does rest for one mean? Let me think about this for about an hour and make sure what the answer is. Or I'm going to email Jose and be I forgot. Okay, how does this work again? But yeah, it's something I'm still a neophyte in. So I don't know if I have a good answer for a supervision tree strategy for that kind of situation.
Well, one thing I just want to mention to anyone who's wondering, one of the things you can do to I don't know a good way to do this with unit tests, but just to interact with your system, there's multiple ways, and I have to look them up, but there's multiple ways to say, do a controlled shutdown on the beam. So you can set off a whole chunk of work and have everything be logging, and then say, do a shutdown. And so you can see what's happening in what order, and just to kind of get insight into that. And the cheapest way, just so you're aware that like Docker, it's assuming you're deploying in a Docker container or something like that. When you tell Docker to stop, it sends a SIG term, which to the OS, the beam process, the OS process, and it hears that and says, okay, I'm going to start a controlled shutdown. And that's like what John was saying, where it notifies all the supervisors and they notify all of their children, and it kind of goes down the tree and starts at the bottom of the tree or the leaves and shutting those down, and then goes up. And so that's how you're able to put in this terminator process that's below a supervisor, and it can tell up higher in the tree, hey, I was told to shut down.
I enjoyed writing that terminator process, mostly because the answer was given to me, and I just had to write it out. But essentially, it was one of those things where, like, when you read the programming Elixir book, you go through all this stuff that's like, here's how you do a send and a receive. Here's a receive block, and here's a loop that you set up. And you get through this whole chapter, and at the end, they're like, and by the way, you basically never need to use this. We have gen servers that do what we just did. And so it was my first experience being like, cool, I'm going to write a receive block here that's listening for when something else is done. Then I'm going to, I've trapped an exit. It was like the most, like, I don't know, hardcore, like the most Elixir I'd done. And I was like, this is really interesting. And that was like a sort of an eye-opening experience, which I enjoyed.
That's cool.
Yeah, I wanted to drop a quick mention. Actually, I'm hoping, Mark, you might have this recorded somewhere. But locally here, Mark gave a presentation. Must be a while ago now, Mark. But I remember you giving a presentation about supervision strategies. And you turned each one of them into kind of like, you anthropomorphized supervision strategies. So he explained each of them in terms of human beings. Now, warning, the metaphor gets very dark when you start talking about managers killing their employees. So, maybe we need to go back to rewording it to like shutting down or letting them go. But as I remember it, it got very bloody during this description. But it works because it's still in my brain. So that's the one way that I ever found to like really remember what each of the strategies do. And also, just as a quick note for listeners, there are totally ways that you can choose to organize your application where you can say, hey, I want to make sure that my flow, all of like my flow supervision strategy or Broadway supervision strategy comes after my Ecto repo. And you still can't guarantee that it's up, right? Databases can go down and maybe your Ecto repo will just be sitting there trying to reconnect, but you can at least guarantee that it doesn't try to shut down until after your flow supervision tree has tried its graceful shutdown. And so definitely ways to solve that. I think similar to John's comment here, every time I've actually done a production system, I squint at it for a little while, and then I open Observer and I like try sending kill signals to the different parts of the supervision tree just to see like if I'm understanding it correctly. So it's one of those things that, maybe when we've all been doing this for like 15 years, we'll chuckle about how we used to not be able to remember it. But so far, the only times I've really had to worry about this stuff, I was setting up things like PubSub, and once I squinted at it and poked at it for an hour or two, I shipped it to production and didn't think about it again for the next year and a half. And so these things tend to not be the things that end up in my Jira tech debt lists. And therefore I don't get as enough practice at them to really commit them to memory, but maybe that's a good thing, or at least it's not such a bad thing. So I'm John, I was curious from your perspective, is when you have people on your team who are making changes to this pipeline, do you find yourself scrutinizing those PRs very carefully? I'm basically wondering, are there cases where it's really easy to accidentally mess up a flow where you want to really make sure you talked about, for instance, using kind of like the transaction approach? Is that something that's really easy for a team of people to get wrong? Or do you generally feel like code changes to your flow, your pipeline are pretty easy to review or easy to get right?
I hadn't thought about that question this way, but I have definitely taken strides to make it hard to mess up. Because we definitely are in a world where, like at Change, where there's this is a sort of a platform that we've built, and so other teams are now coming into it, and I'm currently working with a bunch of different teams on how they can use this platform appropriately. And one of the things that we did from the get-go was essentially try to isolate the flow part of it, the actual like how all these things happen, from the actual code that gets executed each step. So one of the ways they did that, it's a little Ruby-ish, but I for each different message type that comes in, we make a new module. And that module has matches on the name. And so when a message comes in, it does this whole preparation thing where it like decodes the JSON blob and like sets up our internal struct that holds all this data and like, elevates some things, moves stuff around. We got our good message block. And then that struct gets passed through the flow, and each step in the flow, which I think I listed them in the talk, basically like, find what country the user's in and perform some sort of business logic, and then handle like things like suppressions or whether or not this message should continue on or not, and then do side effects. And so then in each, I made it so that when that message comes in, if we know what module it is, we call apply on that to the like business logic function implemented in that module. And so that way it's a clean break. So when someone's adding a new message type or modifying one, they're only working in that part, which definitely still leaves room for errors, but at least isolates it. So when one team is working on one message type and another team introduces another, that they don't conflict or like fight each other. It sort of localizes it to that. And then this is going to be even, I think as we move into a Broadway world, it's going to get even easier. It will just, currently there's a flow processing file. Now there's going to be just like a Broadway processing file. It's like, I'm going to call these 5 functions. Hope your module has these 5 functions defined. I mean, I have now gone through and like made sort of a base message that has some sensible defaults, and people override it where they need it to like make the experience better. But we have another app that I've just converted to this, but that essentially involved a ton of function definitions with guard clauses that were like, we're message type in, and then this list of like 10 different message types. And I'm like, this does not grow. This file is going to get stupid big and we can't handle this anymore. So like the team has now moved to a similar model on that one, where it's like, you add a message type, let's do that. So if I do see a pull request come in and it touches the flow processor file, anything that's not like the message type stuff, my warning lights go off and I go and make sure like what's going on. And I think it's also like other teams don't even know what that file is, and they don't need to. They just need to know my message needs to do these things, and John's team will take care of the rest. And that's essentially where we're at.
Developers are people just like us. And a lot of times they have really, really interesting stories about how they got into a programming language, out of a programming language, how they got into programming in the first place. I can't tell you how many people I've talked to that have a degree in music or have some affinity for music, or maybe they have a degree in something else like theater, and then they wound up getting into programming for other reasons. I actually used to work with a whole team of people that all had law degrees that wrote code. It's just interesting to me how people have come along in their careers as developers. So we have a show for you. So if you're into Ruby, go check out My Ruby Story. That's at myrubystory.com.
But I will say that even you can still, while the individual sort of message type modules that people put in there don't conflict with each other directly, we are careful to be like, so you've added one extra database lookup, and now imagine 15 million messages come in simultaneously. We just added 15 million database lookups that are all going to try to happen very close to each other. Like it's not going to overload anything because the back pressure won't allow that. But like, let's think like, now let's monitor this, or like, let's make sure this query is efficient and that kind of stuff. And be ready to come up with another solution if that's not, good enough. So those are sort of the things that are concerned. And I can't say that I'm totally relaxed about this because I just enabled blocking PR requests on all the master branches on all these projects. So somebody from my team has to look at it, just to sort of make sure as we're spreading the love of Elixir and the knowledge of how the system works. But I got a little spooked by a recent pull request and was like, I'm locking all these down. And so that's where we're at now.
That's great. Yeah, that is interesting, especially when you're talking about an aspect of the system that is very central in terms of critical to the business function. And it is very, you're talking about the desire for high throughput. And so, yeah, that is, given any situation, any company, that is that process you want to be more aware. It's like the critical path for your program, for your system. So yeah, that's cool. Thanks for sharing that.
The other sort of side thing is that we built a system with an eye to, like, I'd like to say it was very smart of me to make those things separate early on, but it was essentially because as a team, we wanted to open source the stuff that we were building, and this like sort of generic data processing system. My team needs to get together, and since the release of Broadway, which essentially does what we were thinking of doing, like we need to reevaluate that. But like that was one of the original goals, was like Change wants to get it and wants to have some open source repos and want to continue and do more in that space. And everybody on the team is on board with that. And so like that was one of our big goals. And now it's been we need to revisit it and make sure that that's still something we're shooting for.
The last time I was setting up a pipeline like this, I had sweaty dreams at night where I was imagining someone putting in specific kinds of bugs that would actually bring the entire pipeline down all at once. So I think your concerns sound totally valid, but it's pretty amazing the level of isolation that the Beam gives you at kind of that actor process level, and how building on that abstraction, you get you have a lot of optionality in terms of what isolation you want to guarantee. But it sounds like if somebody put in, a bad piece of code for one type of message type, it could have an impact on the overall system, but wouldn't just halt the whole thing from the ground. It's not just going to like freeze the wheels on this thing and crash into the ground.
Yeah. Worst case, we're going to get slower throughput, and that queue gets backed up too much. I get paged, and we start getting into it.
So if someone is wanting to get started today with something, would you direct to doing a pipeline where they're processing data, maybe pulling from a queue, something similar to what you're talking about doing? Would you direct them to say, hey, check out Flow because it was totally awesome for us? Or would you say, just start with Broadway?
Classic programmer answer. I think it depends. I would basically want to find out what they're doing. And if what they're doing maps more similarly to what we're doing, where there's like a external source like SQS and you need to process things and you need some complex batching, then I would shoot them towards Broadway. I think like in our case, if we didn't need to batch going in or out, our flow would be what they classify as, I forgot the term. I think it's ridiculously parallel. And we would just use flow and it would be great. I'm missing the details, but I remember reading a blog post that sort of like enumerated those differences. And so that's why I always think of like Flow and Broadway are both like siblings, with GenStage being their parent. And so they're built on the same concepts, but like pushed in slightly different directions. And I mean, when it gets down to it, what I think the main difference is the partition or the demand dispatcher. Where in Flow, it's demand driven. It's dispatched to an event comes in, it's dispatched to the GenStage that can take on more demand. Whereas in Broadway, because you can do like a set partition on it, I think is what the terminology they use. You can, the dispatching is a partition dispatcher instead of a demand dispatcher. And so then it just dispatches like, oh, I ran a SHA on this thing and I got this number, so it goes to this one, even if that one is backed up. But like, that's how we want it for this. I think that might also help. One of the problems that I'm digressing. Essentially, it's those are the sort of the determining factors that I would think about in doing this. I have had like somebody at MPEX came up to me after the talk there and was like, how do you make sure that they happen in an order, or in an order for a specific user? And one of my responses in Broadway was just coming out at that point, and I was like, I think partition dispatcher is kind of what you want, and then you at least get them localized to users. And then if you have like whenever they get shipped off to wherever they go next, like you could even sort that partition or do something with it to make sure that they're at least like that batch is in some sort of order, as long as you have something to sort them on.
Yeah, I have to say, when I first was reading about the Broadway batchers, and they have like windowing functions and all sorts of interesting things. And I immediately thought back to months of my own life that I spent writing a Ruby system that was for user notifications. And it had an enormous amount of very tricky database queries, all around the fact that some messages were guaranteed to like deliver immediately. Others would kind of batch up and wait for up to 5 minutes for another message so that we could kind of like take multiple messages and cram them into one email and not flood your inbox. But things like password resets bypass that. And so there was like all this conditional stuff all over the place that was handling these things. And the first time I saw Broadway, I just thought, oh my gosh, where were you 3 years ago when I needed you? So I haven't written such a system yet since Broadway, but eagerly looking forward to the chance to both be demand driven and have the ability, like, you know, in that system, it was completely unfeasible to have a Ruby worker per user. No one's got enough CPU or RAM for that. But it would be no problem at all to have a partitioner that is going to partition things by user ID. And even, you know, if I end up with, you know, 10,000 active users receiving messages at a time, that's no problem. The Beam's going to be just fine to have a process per user. And if you have 10,000 users or 100,000 users, you're still good. And if you need a few million, maybe you need 2 nodes. You know, that's a pretty amazing place to be.
Oh, I will mention one thing that we have a similar thing where there are certain messages that can be batched and some that like need to go through immediately. And we try to come up with a very simple solution, which is essentially to have 2 instances of our system running. And they have a different SQSQ, one for like the default and one for like priority lane stuff. And that's turned out to be like really nice because it means when we write in the actual system has no idea which pipeline it's in, whether it's in the default one or the faster one. It knows which messages it can batch or not, but we can then arbitrarily as we drop it into the queue, we can say this one's priority and it will go in the priority queue and everything else goes to default. And that makes it easier conceptually when people are writing the code that they don't have to care. It's like advantages happen in both systems and we just essentially, you know, spin up 4 nodes instead of 2. And that has worked really well so far.
All right. Well, is there anything else that you think we should mention or talk about before we move on?
No, I don't think so. Actually, there's one other thing that I've been noodling on that I'll mention here that one of my coworkers and I have been working on, which is trying to not really just look for other uses of GenStage and Broadway and Flow, but we have had a situation where I don't know if you guys are familiar with Amazon's Kinesis Firehose, but it's essentially like, oh, sorry, you know?
I understand it. It's like Kafka, but it's a managed service. But I've never actually used it. I'm just aware of it. And I'd looked into it once trying to figure out if it would solve a particular need that we had. But yeah, I'd love to hear what you have to say about it.
It's interesting because we have a situation where we want to have large scale analytics on all the stuff, or the actual like business side of what's passing through our system. And so one of the ways that we do that, and the fastest way that we could find, was to log things to a Kinesis Firehose. I mean, we're totally in the AWS ecosystem. And that has a mechanism whereby it can then pipe this data through S3 directly into a big Redshift data warehouse. And that's where our analysts can then look at it. But in order to do that, there's no client for Elixir. So what we do is we just use a backend logger and log all these events to a text file, and then have the like Java Kinesis agent reads through that file and pipes those messages into Kinesis for us. So as we were talking about shutdowns earlier, this is a thing that came in where we ran into this whole thing. We weren't even using Logger. We were using the Erlang disk something. It's another function that's even faster than Logger. It's one level lower, like disk sync or something. And we had problems where like the Kinesis agent at restart time wouldn't let go of the old log file. And so then we like had to do all these weird things where we're like in log rotate, say, oh, also restart our service every time you change the log so that things will break and we ran into this weird situation where like the agent would forget that it read part of a log and it would read the whole thing again, and so we'd get some like extra data in there. So that's all the setup. But essentially we were like, there's got to be a better way than this, because we're writing the stuff so fast that like it's not like Logger couldn't keep up, so we switched to this disk sync thing, I think is what it's called. And that's now we have this like weird case where if like a big thing is happening right at log rotate time, where we have the potential for like some data to get duplicated. So we thought this sounds like a thing that we could solve. And essentially one of my coworkers, Justin, has put together this library called Kinesis Hydrant that we talked about a few different ways to do it. And one of them is what he's using currently, I believe, is a gen stage setup. So our flow keeps moving and is still back pressure driven, but every time it needs to write out, it will cast out to essentially like a gen stage. And those, I think it's like a producer essentially, and it pulls in those messages, and then it can be, then that logging mechanism can be its own different flow. And then it can be back pressure driven at that point. Once the messages get over to it, then it's suddenly back pressured, and it then uses the XAWS library to like fire out to Kinesis. So we're not writing to files anymore. And we have this other system. And this is where, as you talked about like system shutdowns, this is how we had to test it, because there needs to be a thing where like that queue needs to get flushed. Or in our case, we just take whatever hasn't been sent and we write it to a file. And then when the service comes back up, the first thing it does is look at that file and finish processing it and then move on. And so like that was another, I was trying to be like, dude, use Broadway for this. Let's figure out how to fit this in there. And it was a little like, a case could be made for it, but it's not necessary. So that was like another sort of side thing where we were like, that's probably not the right fit. But I think just like a simple gen stage worked well enough, and we didn't need to like then go to the next level of flow. So like that was a weird side problem that has come up from this, essentially because the system is going so fast that things could not keep up, which I think is a good problem to have. But that's where we're now like looking around, like how can we make other things better with these learnings that we've got from this high volume data pipeline.
That is cool. That is nice when it's like, oh, our system is moving too fast. It's just processing too much data too quickly, too effectively. What are we going to do? I don't know. That's great. I love it.
Put in timer.sleeps everywhere.
Then make people pay for the pro version. Turn them off again.
Would you like to expedite your signing of this petition?
Amazing.
Well, that's probably a good place to wrap. Let's move to picks. Michael, do you have one you can share?
Sure do. This is going to be a little bit of a general pick today, but I had a friend who recently messaged me, and he's like, oh, we have, they moved to a new house. They have a gate, and they want to be able to open it when a friend is coming. And, but the latch is a physical latch, and it's a little ways away from the edge of the house. And he's like, please tell me there's a way to solve this problem. And it really just, again, reignited my love for nerves. So I'm going to drop a link to the nerves project. And it was amazing to kind of like talk through. We just started, brainstorming ideas. But essentially, I think it's just going to come down to like one Raspberry Pi Zero, an SD card, a USB power source, and one servo motor. And I think that's going to be everything he needs to make it so that they can like remote control their gate, which is just so cool. We live in an amazing, amazing time where we can choose to waste hours of our time doing something with technology that really only costs us 10 steps. So 10 physical steps. So in any case, I love to waste some of my free time doing those kinds of things. And if other people do as well, the nerves community has been picking up a lot of steam. It's continuing to move quickly. And I know there's going to be a lot of trainings at ElixirConf this year. I'm sorry I'm not going to be there for many of those. But anyway, if you're interested in doing something silly, check out Nerves Project. Feel free to hit me up as well.
That's great, Michael. Since we last spoke, I have back at MPEX, I have become a homeowner, and immediately was like, I'm going to go watch Michael's talk again and figure out how I can jam a bunch of Raspberry Pis all over the property.
Nice.
Amazing.
Oh, that's great. All right, so I'm going to pick it's a tool called AvidMux, and I need to find a link to it. I'll put that in the show notes. But it's an application. It's cross-platform. I use it on Linux. And what it is really good at is trimming video without re-encoding it. So you can't do it with all file types. It works great with MKVs and I think MP4s, but it might have to convert the MP4 to MKV, but it does that very quickly. It's just a container change. And what's really handy with it is like, say you have like a recording of something and you want to pull out a clip. It's just a great way to just like grab, a segment of the of the video and extract that because maybe you want to post that separately, or you're just wanting to, share that with a friend. I've also used it. My wife's family, they had some really old VHS tapes. And so they took them to some service that would convert VHS tapes into DVDs. And they literally did the least amount of work that they could, which is put it into the machine and have it convert and record and then walk away. And so this video might have 20 minutes of actual, something you care about, Christmas morning, something like that. And then the rest of it's blue screen. And it's a 4 gigabyte file. And it's okay, this is really stupid. And so it's just using AvidMux, I could just go clip, slam off the rest of it and save, and I'm done. It's I don't have to re-encode it, which would take hours to do all of these different files. So AvidMux, that's a fun one if you have to deal with video files. So that's it for me. And John, what do you have?
I've got two. One programming that probably has been picked on the show before, and then one non-programming. But the first one is, I go back to this talk all the time, and it's Sasha Urich's Solid Ground talk at MPEX 2017. Yeah, it's such a good talk. I can see by your faces you guys agree. And I show it to people on my team when I'm trying to explain how scheduling works on the beam and why it's not a problem when I tell DevOps not to auto scale when the servers are at 95%, that's fine. We're pretty good right now. We need to find a different metric. So and going through that video is just it was eye-opening the first time I went through, and I was this is amazing. This is such a good use of the beam that blew my mind. And I think everybody should see it. So I'm going to shout that one. The other one is a fun one. If you happen to have Netflix, there is a show on it called, in English it's called Money Heist, but it's a Spanish show, and it's called La Casa de Papel. And they just came out with a part 3 of it. The first 2, I haven't watched that yet, but the first 2 were so good. And it's basically a bank heist movie, but they rob the Spanish treasury. And it's just I don't know, it's super cool and fun. And my wife and I really enjoyed watching it. And now there's a 3rd season, and we're just oh my God, what's going to happen next? It's one of those very excited that it's out now. I feel heist movies, that's a good one. Those are my picks.
Great. Well, that's some fun stuff to check up on. Well, John, I know we had a blast talking with you. And if people want to follow up with you or get in touch with you, where would you direct them to go?
Basically everywhere on the internet, I am Mertonium. I'll write that in the show notes. That's what happens when you pick a handle when you're 18. I'm far from 18 now. But yeah, the Twitter, GitHub, website are all Mertonium.
Great. I am at Brainlid.
And I'm at Ries.
And that's it for today. Thank you for listening, and we hope you'll join us next week on Elixir Mix.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN.